The first thing we need to be able to do to find the volume by washers with these 4 lines is to actually graph the functions. So this is a quadratic function, upside down because it's negative and shifted up 4. So it looks like this. And in blue over here, this is a linear function with a slope of 2 and a y-intercept of 4. So down 2 over 1, down 2 over 1. So that linear function looks something like that. So it says that we're going to take this area here and revolve it around these 4 lines. So first we'll revolve it around the x-axis, then the y-axis, the line y equals 4, the line x equals -2. So we're actually not going to actually solve for any of these, we're just going to set them all up. So one thing that is helpful to point out is the actual limits that we're going to be looking at. So in terms of x, we look at x limits, and in terms of y, we look at y limits. So if I look at these coordinate points, the furthest point to the left is -2. The furthest point to the right is 0. So when I do everything in terms of x, when I'm revolving it around a horizontal line, I'll go from -2 to 0. And in terms of y, the furthest point to the bottom is 0, or the lowest point I should say, and the highest point is at 4. So if I'm revolving it around a vertical line, I'll go from 0 to 4. So you'll notice that I do that at various times throughout the video, is that if it's in terms of x, from -2 to 0, if it's in terms of y, from 0 to 4. Alright, beautiful. So let's start with the x-axis. As far as your SIG test is tomorrow, there's many different ways that you can write your answer, but you'll see the way that I write it today just because I want to make sure that it's as in simplest forms as possible for myself. So I'm always going to go ahead and list out my capital R and my lowercase r. And then from there, because these are all volumes by revolution, the integral formula is the same every single time. It's always pi times the integral. The limits will change, but times the integral of, and actually let me move this up a little so you guys can see this. It's volume equals pi times the integral of capital R squared minus lowercase r squared d something. So it's either dx or dy depending on which line we're revolving it around. So I'm just going to kind of keep that there right now. That's kind of my my basis that all 4 of these parts are going to look like this. I'll have a big R, a little r, and then it'll all be plugged into this formula. The limits will change depending on what I'm revolving it around, and either dy or dx will change, and my capital R and my lowercase r will change, but everything else will stay the same. So let's look over here, and I'm going to just erase some extra stuff that we don't really need. Oops, let me do it with this. So like for example, we don't really need any of this, or this, or this. So we really only need that piece of the graph because that's what we're revolving. So I'm going to go ahead and do it in green so you guys can see it. So the first one we're going to revolve it around is the x-axis. So the x-axis, I'm just going to draw the inside ring, and I'll draw the outside ring. And remember that that ring is always going to be centered along this axis of revolution. So if I look at the inside, all right, the inside, or sorry, big R. So I'll look at the outside first. From the x-axis up to this function here, all right, this is the upside down quadratic function. So the distance from the x-axis up to there would just be the equation of the quadratic function. So I'm just going to write, and I'll do it in purple so it's easy to see. Negative x squared plus 4. That's the distance of the radius from the x-axis up to the top. From the x-axis to the bottom function, that's to the linear function. So the equation of the linear function is 2x plus 4. And then again, because I'm revolving it around a horizontal line, I'm revolving it around the x-axis, I'm using the x limits. So it's going to be from -2 to 0 dx. So everything's in terms of x. My equations are in terms of x, my limits are in terms of x, and my integral is also in terms of x. So those are really the only things that are going to change for every single one of these, is what my big R and little r happen to be, as well as my limits and what this should be. So that's part A. So we're done with that one now. We did the x-axis. Now let's move on to part B. So let me kind of erase some of this work. And notice that I'm just going to kind of keep a framework here for what we're working with. So there, I'll take us up. Oh, actually, I'll erase some of that stuff I didn't need either. There. We got up to about, oh my gosh. There, perfect. Okay, let's go back to the drawing board again. So we did the x-axis, now we're going to do the y-axis. So if I draw rings around the y-axis, and again, I'm going to center them around the y-axis, I draw the inside ring, and I draw the outside ring. Alright, so it looks like this. Capital R is going to be the distance from the y-axis to this point. Alright, now please keep in mind that now that we're revolving it around a vertical line, everything needs to be in terms of y. So we kind of need to do a little bit of work down here, because right now these equations are in terms of x. So we have y equals negative x squared plus 4. To solve it in terms of y, I subtract 4. Divide by a negative. So when I divide by a negative, I can actually just switch these. So it's going to be positive 4 and negative y. And then take the square root of both sides. So x equals the positive and negative square root of 4 minus y. Now, it just so happens that this side of the parabola is the one that's the negative square root of 4 minus y. And you can test that. I mean, choose y values that any y value you want. So for example, excuse me, if you choose y equals 0, you get 4 minus 0 is 4, the square root of 4 is 2, and you want it to be negative 2. So that's obviously why you're choosing the negative side. So I'm going to go ahead and just cross off that we're not going to use the positive one, we're only going to be using the negative one. So that's the equation of this outer function now in terms of y. So the distance from the x-axis to that function is the negative square root of 4 minus y. So here we have the negative square root of 4 minus y. The distance from the y-axis to the inside function is just the distance of the other function, but again, we need it to be in terms of y instead of in terms of x. So let me erase this work that I did right here. And now if we want to solve that one in terms of y, we have y equals 2x plus 4. Subtract 4 from both sides, so we get y minus 4 equals 2x, and then divide by 2. So I have y minus 4 divided by 2 equals x. And again, the distance between the y-axis and that point is going to be this function here in terms of y. And you can always check it. If I choose y equals 2, for example, I get 2 minus 4, that's negative 2. Negative 2 divided by 2 is negative 1. And it is true that this is a unit of negative 1. So I'll write that up here. I have y minus 4 over 2. Alright, so again, my capital R, my lowercase r. By the way, in case you were wondering, like obviously these are radii, which are supposed to be positive values. And so, you know, we just saw that if I plugged in 2, I get y equals negative 1, which doesn't really make sense as a radius. But because we're going to be squaring them, it doesn't really matter that they're giving us negative answers, because the squaring it will take away the negative anyway and make it positive. So these are just the equations in terms of y. You don't really need to make a difference between the positives and negatives. So that's okay in that response. Alright, our limits. Remember that now that we're in terms of y, our functions are in terms of y, our limits also need to be in terms of y. So instead of going from negative 2 to 0, because those were x limits, we're going to go from 0 to 4. So our limits are from 0 to 4, and our equation is dy. So again, notice that nothing changed other than the inside and outside radius. Our limits changed and our dy changed. So let's go back again so that we can do part C, the line y equals 4. Alright, so we have done the x-axis, we've done the y-axis, and now we're on the line y equals 4. So let me actually graph that line in red. Looks something like that. So when I draw my lines, or I'm sorry, I draw my rings, I draw my inside ring, I draw my outside ring. Alright, so the distance from the line y equals 4 to the outside ring. Okay, we're back in terms of a horizontal line again, so we want everything in terms of x. So the distance from here to here, remember that from the x-axis up to this function would have been just the equation of that linear function. But the opposite distance from the line down to that equation is the line minus that function. So it's going to be 4 minus the linear equation. So it's going to look like 4 minus 2x plus 4. And then for the inside ring, it's going to be the line minus the quadratic equation. So it'll be 4 minus negative x squared plus 4. And you can simplify this if you want to, but you don't really need to because for the purposes of the signature test at least, I just want to know whether or not you can identify these. It would be very easy to plug that into your calculator and have it solve it for you, so it's not a priority of mine for you to be able to simplify it. The limits, now that we're a horizontal line again, we're going from left to right, so we're back at looking at the x limits again. So the furthest point to the left is -2, the furthest point to the right is 0. And we're in terms of x again, so that's dx. Alright, so that's the revolving it around the line y equals 4. And then last but not least, if we want to revolve it around the line x equals -2, let me draw that line. That would be right here. So if I can do my best job at drawing these rings, I have my inside ring and my outside ring. We're back to a vertical line again, so remember everything needs to be in terms of y, so our two equations in terms of y were x equaled the negative square root of 4 minus y, and x equaled y minus 4 over 2. So those were our two equations in terms of y, just in case you forgot what they were. Now for this one you have to be careful about which one you put on top and which one you put on bottom, just because it might make your answer negative, and you just want to be careful and you want to be consistent. So remember that we always want our answer to be the top function minus the bottom function, or in other words, the how can I put this? We want it to be the greater value of x minus the lesser value of x. So if I look at these, and remember I always tell you to turn your head to the right, or tilt your head to the right. So if you tilt your head to the right, this would be the top function, and then that line is the bottom function. So if I look at my outer radius, all right, I'm going from the linear function back to this. So I'm going to take the equation of the linear function and subtract the equation for the axis of revolution. So the linear function is y minus 4 over 2, and then the axis of revolution is at -2. So if I write that for capital R, I have y minus 4 over 2 minus the axis of revolution, which is -2. So notice that that's going to create a positive. If you want to write it as a positive right now, be my guest, but I don't necessarily need you to. And then for the inside ring, the top function is going to be this quadratic function, and the bottom is, again, the line -2. So I'll write down the equation for the quadratic function, which is negative square root of 4 minus y, and then I'll put minus -2. And again, if you want to change that to a positive, you can, but it's not necessary. Because we're revolving it around a vertical line, our limits are back to in terms of y again, because we're revolving it up and down. So the lowest point is 0, the highest point is 4. And this is in terms of y, so it should be dy. I understand that this is probably going to take you a little bit longer than 5 minutes, so expect to have a little bit more time on this one tomorrow. But as a general idea, that's all that you have to do is to create those integrals. Mainly looking at the limits, looking at the variable you're using, and making sure that you have your capital R and lowercase r correct.